I'm really excited to be here with you today and being able to, thank you, being able to share a few thoughts about Willy and teaching with Willy, which I learned to do from Willy. I had joined the department, and the last thing in the world I wanted to do was to become a professor. And then things happened, and I ended up being one. And I hated the idea of teaching. I didn't know any happy professors until, of course, I met Willy. He was not only happy, but happy to teach. And I had a great grand fortune of teaching with him initially. And that's how I fell in love with teaching. And now it's actually one of my favorite things in the world to do. And I owe all of that to Willy and to his incredible charm. That's why my talk is about teaching with Willy. Then can you move that thing? I moved it aside, but it didn't stick. Teaching with Willy and enjoying Willy in retirement, mostly. Most of our friendship was actually after he retired, which was in the early 2000s. And then with him cooking with Willy and Gabby and doing all sorts of other things. So as I said, I started teaching with Willy. This is the room we first taught in, which is that room right there, 1313. That has a great historical value for us. It always had. We were very upset when they restructured this building. We actually moved out of this building. This is totally foreign to us. Dan and I had to familiarize ourselves with the AV system here because it's completely different from what we use every day. But that room was flipped around. So this is the way it used to be. Now, actually, it slopes the different direction and people are oriented differently, but it's the same room, same number, same size. And this is the first class we taught together. Unfortunately, I don't have any photos of us teaching, but I have a photo of the students while we were teaching to them. And I, in fact, recognize quite a few of those people. The clicker is not working. Yeah, exactly. Okay, so it should work now. Yeah, perfect. So Willy had many wise opinions. At times he was a bit grumpy, but mostly he had great wisdom and he was well worth listening to. And so one of the fantastic things that he did was to rely on practical demonstrations, which we call lecture demos. And for teaching physics, that's what we relied upon most of the time. So here we see the law of reflection, here we see the law of refraction, and I'm not going to bore the non-physicists with the details. This clicker is annoying me, but setting up any of the really complicated pieces of equipment we had to set up ahead of class, then he would actually tinker with it until it worked absolutely perfectly. And then he would go, there. So I want to show you Willy's favorite demo, which he actually invented. And I've seen him giving it at a theater. I've seen him giving it in class. I've seen him giving it at public talks. And I've actually given it myself at public talks, at the theater, on a TED Talk, and so on. It is a really delightful demo. And I'm going to share with you the pleasure of how well it works. So we have two projectors here. I need to switch the lights. Lights. So we had two projectors. One of them has a red filter. And as everybody knows, when white light goes through a red filter, it looks red. All the red wavelengths of the spectrum are transmitted and none of the other colors are transmitted. So there's no yellow, there's no blue, there's no green that's going through that filter. Those wavelengths are absorbed by the filter and red is transmitted. As Willy will put it to the general public, The other wavelengths or the other colors are eaten up by the filter and the rest is transmitted. So clearly, if you now look at another white light projector where you're actually not only going through white light, but also transmitting the white light through a slit. So there's a vertical slit. This is not dark enough. Can you make it off, the lights off? That white light is now going through a slit and through a prism. So we have a first refraction, a second refraction, much better, thanks then. So now you see that white light from that projector is actually dispersed. It's split up into the various colors that compose it. So if I now take this red filter out of the white light projector and put it in front of the prism projector, as you can see, all of the other wavelengths are eaten up and only red goes through. Please note that there's no yellow, no green, no blue there. Let's do the same thing with a totally different filter, green. Green goes through. Is it true on the other spectrum projector? Indeed, it's true there as well. No red is going through this filter, no yellow, no blue, all eaten up, as Willy would put it. So what will happen if I now put this red filter in front of one projector and I switched on a second projector here, and I actually put the green filter in front of the second projector? What will happen if I actually pointed the two projectors to the same region on the screen? Would we see a different color? The answer is very much yes. And what color would that be? Does anybody want to guess? Brown. Yellow? Other opinions? Blue? Other opinions? Okay, let's do the experiment. We're physicists, we do experiments. The color is yellow. You should be surprised because I just showed you in the first part of this experiment that there was no yellow going through the first filter. There was no yellow going through the second filter. What's yellow doing there? No answer, really. What's yellow doing there? There are no yellow wavelengths. This is the way Willy would present it, and I totally loved that because he would just make everybody feel like a complete idiot and say, this bell is magic. This thing happens all the time in the screens of our cell phones, actually. So it's called additive color mixing. When you have the additive mixture of red and green, you actually generate in the eye the perception of yellow, but there are no yellow wavelengths there. Those filters were not lying. They really were eating up the other wavelengths. They were, in fact, absorbing all wavelengths, including yellow, but then the overlapping of these two gives the perception of yellow. I've done a lot of research on this particular issue, which entailed the figuring out this much later article. If you could read the date, that's actually year 2000, but Willy figured this out much earlier than that. This is a very difficult experiment that was done by people in neurophysiology, measuring on macaques, on monkeys, the retina, and figuring out that there are actually three types of cone cells. So these are neurons at the back of the eye that perceive different wavelengths with different intensities and then send a message to the brain. So if we had the long wavelength sensitive cones, that's their sensitivity curve. I plotted it in red. I labeled them L for long wavelength, medium wavelength, short wavelength, and I gave them colors, although it's by no means true that these are only sensitive to red, green, and blue. But they correspond, as you can see, to the spectrum that I put with their corresponding wavelengths in nanometers at the bottom of the graph. So if I had a specific wavelength that I wanted to display on this plot. I could, for example, show you the wavelengths I showed you before, which would be, and I'm simplifying a little bit. Let's assume that these are two laser pointers, for example, one that's red at 633 nanometers of wavelength and one at 520 that's green, like the one I'm holding right now. This would generate three different signals on the LMS cones. On the L cones, there will be four for red. It will be 0 and 0 on the MS cones, respectively. If we were looking at a green laser pointer instead, we would see that these intersect at 0, 6, and 7. So the brain would receive those numbers and add them up. So focus on one in particular. Look at this L cone, for example. This would receive, when we look at the area of the screen there where the two colors overlap, what happens is that the L cone receives 4 from the red part of the filter or the laser pointer, and 6 from the green stimulus, and we'll add them up. This is why we call it additive color mixing. It is not true that the screen of our cell phone does additive color mixing. Our eye does additive color mixing. And in fact, each type of cone independently does additive color mixing. And then it sends the brain not 4, not 6, 6 plus 4, which of course is 10, but there is another color that would generate precisely the same triplet of numbers. So when receiving for red 10, 7, and 0, for red plus green is 10, 7, and 0, and for yellow is 10, 7, and 0, precisely the same numbers. The brain has no way of telling the difference between mixed yellow and single wavelength yellow, or so-called spectral yellow. So that's the physiological way it works. It takes a lot of neurobiology to figure this out. It takes a lot of precision measurements, but you can see it directly with your eyes. And Willy understood this before all of these measurements were possible. Another piece of wisdom from Willy was that always do the easy experiment first. And some of you might recognize this. So he came up with very complicated experiments, but he always did the easy ones first. And I've learned this as a lesson in the lab myself. And it's constant decision making while doing experiments. Always do the easy one first. You learn so much by screwing up the easy experiment that then you do it right when it comes to the complicated experiment. So let's see a different experiment that Willy truly loved. For this, I need some different equipment, which is here. When Willy was pretty grumpy about people, as you remember, sometimes he would be really, really upset at something that happened, say Bush got elected or something really annoying, and he would go, people. And that's the way you will hear, people. And not actually say what was so annoying about people. It's just the people are people, as he would put it. But in helium, he would say, people. Sulfur hexafluoride.
He would say, people. How could he possibly get along with the world? It's full of people.
No need to applaud. I wasn't bowing at you, although you fully deserve. I was just emptying my lung. So I kind of need to breathe from now on. Yes, what did you just say?
You're exhausting the heavy gas from your lungs.
Exactly. Bravo. You know physics. So how does this work precisely? Willy will not be happy without showing you the formula. as I was able to measure recently, I actually took the Fourier spectrum of a student of mine who's a singer and determined that the windpipe is actually an open pipe, which surprised me. I could swear it's actually a closed pipe. And so in the case of a closed pipe, it would be the frequency would be the speed of sound divided by 4 times the length of the windpipe. But all the Fourier components are there, therefore it must be an open pipe. The opening presumably on the opposite side being my lungs, I suppose. So the windpipe is basically a pipe that goes, not sure where it starts, in the mouth, the throat, someplace there, and then it stops before the lungs, but it's open at both ends, mouth and lungs. And so that's the key point. So that's the right formula. And the speed of sound increases. If the speed of sound increases, of course, the frequency increases. And so in helium, I would go people, and in sulfur hexafluoride, I would go purple, a much, much lower frequency. Why? Because the speed of sound in air is 344 meters per second at 21 C, at room temperature, whereas sulfur hexafluoride, it's approximately 1/3 of that, and in helium is 3 times greater than that. So these are significant changes. This is why the demo works so fantastically well, and Willy loved it dearly. So he taught me how to teach, and he was incredibly charming when I won the teaching award back in 2011, which to my greatest dismay, he actually never won himself. He really should have. And so when I won it in my acceptance speech, I actually dedicated the award to him, saying that he should have won it because he deserved it way more than I did. Anyway, Willy was so charming, and he and Gabby both came and were there for the entire ceremony and celebration. It was lovely. Clicker, please work. So when Willy died in October 2021, he was 96 years old. However, some parts of him were a lot younger. He had a hip replacement. It was a metal one. It was on the right hip, as you can see. And so not all of him was 96 years old. He also had a pacemaker. And so some pieces of him were a lot younger. Oops. It wouldn't be a Willy talk if there wasn't something sassy at some point, right? Food has to look good at all stages of preparation, not only on the final plate, which of course was always a masterpiece, but it had to look good in the kitchen during preparations. And so it was fantastic to cook with Willy because it was a masterpiece of sculpture all along, from the raw ingredients at the farmer's market up until the final product. So we did a lot of cooking together. As I said, most of my friendship with him was in retirement, when he was retired. And so here you are seeing his favorite Sunday meal with Gabby. And a few times I was invited along. And these are his famous eggs Benedict. Come on, baby. That consists of poached eggs and hollandaise sauce, or at least that's the usual recipe. And they instead made the addition of smoked salmon and avocado, and it's immensely better with this addition of flavors. I learned a lot from Willy, and specifically I learned how to poach an egg and how to make mayonnaise. You know, you should add water to mayonnaise. If the density is a little too high at the end, you just add water. And that was a perfect trick that I hope you'll remember. I was actually disappointed that in the recipe book, there were no eggs Benedict, because these two additions are worth making. Okay, so these are Willy and Gabby in their kitchen, and Willy is taking stuff out of the oven, and those are the fantastic eggs Benedict that Gabby is carrying. So for domestic happiness, he recommends in his great wisdom to cook together. And that worked wonders for him and Gabby. I remember Paula asking him, what movies do you watch in the evening? And he gave this answer, we cook together. We don't watch movies. And Paula said, that is so romantic. I love that. Okay. This is Willy at our condo with my husband, Ben, making wontons. At one point, he learned how to make wontons, and so he wanted to share this new skill, and we all started making wontons all the time. It was delightful. This is Il Flottant that Willy and Gabby made for my birthday, knowing that I like it so much. They made it for me. They didn't tell me they were gonna make it for me. It was a complete surprise. I was so happy. We had never spoken about it. In fact, now I think about it, they didn't know that I liked it so much. But then when Ben and I tried to make it, it looked very, very different. It was a lumpy mess. So Willy, that's another very funny part of his wisdom. And it is that, oh, I'm running late. I'm going to keep it short. Okay, so when we wrote 3 books together, and we spent an immense amount of time, and we had a very big profit, like 3 pennies in royalties. And he had great wisdom that came from his mother that said, a louse in the cabbage is better than no meat at all. So I'm running out of time. I'm going to skip to the end and show you the photos that I didn't even know were taken, actually. This is the last time I saw Willy alive. It was September 26. He died in the early hours of Monday. It was a Sunday night. A week later, and just a few hours more, because he died early the following Monday, very early morning. So really a week before he died. And I brought him 2 gifts, and I'm so glad I did, because it was the last time I saw him. And one gift because he couldn't see anything and he could hear very, very little in the end. So I brought him a baby alpaca pillow because he could touch it. You know, how do you entertain somebody that can't see and can't hear? It's not a trivial thing. What do you bring them as a gift? And so I thought something sensory is probably the thing that could entertain him for a fraction of a second. And he loved it, and he kept petting it all evening, and it was really, really lovely. And he said he wanted it, wanted me to put it on his bed because that way he could stroke it at night. And also I brought him some spices. I don't know if you guys know Pansy Spices, this fantastic store in Madison that is like a museum of smell. That's something he could do. He could see, couldn't hear, but he could definitely smell. So I brought him a bunch of little jars with all sorts of spices that he could obviously use in the kitchen, but it was just to entertain his olfact, his sense of smell, while he first saw them. And so we had this game in which I would open the jar, pass it to him, and he would have to guess what smell it was. And the reason I'm showing all of this to you is that when it came to ginger, I don't know if you can see there, but the jar was overly full. So when I unscrewed it, it kind of bulged out. And he has quite a bit of it on his nose. He basically put his big nose into the jar. And of course, the ginger made him sneeze and cough, and it was a mess. And that expression of his is so fantastic, and I want to remember him like that forever. He was so charming. Goodbye, Willy. You will always be with me.